This pile of copper pennies contains almost a trillion atoms of copper. To be exact, it contains 6.02 times 10 to the 23rd atoms of copper. Because atoms are so incredibly small, it takes a huge number of them to make up enough material that we can actually work with them. Because all of chemistry happens on the level of atoms and molecules, it's going to be important for us to understand how many atoms or molecules are contained in a macroscopic workable amount of a material. To do that, we are going to introduce the concept of a mole. The first thing to understand about a mole is that it's just a number, just like 1 dozen means 12, 1 mole means 6.02 times 10 to the 23rd of something. For a chemist, we're always working with large amounts of atoms and molecules, and so if we talk about them in units of 1 mole, we don't have to write huge big numbers every time we want to talk about how many atoms or molecules we have. So just like I might say that I have a dozen eggs, and you know immediately that I have 12 of them, I can say that I have a mole of atoms, and you know immediately that means I have 6.02 times 23rd of them. The second thing to understand about a mole is that this number was not picked at random. It's picked in such a way that the atomic mass given in the periodic table for each element is equal to the mass of 1 mole of that substance. So just like carbon weighs 12.001 AMU per atom, it's also fair to say that it weighs 12.011 grams per mole of carbon atoms. Thus, the atomic mass for any element has the same numerical value as the molar mass for a given element. The atomic mass is the mass per atom in units of AMU. The molar mass is the mass per mole in units of grams.